Good morning, this is your stat sensei, Mr. Spensei, and we are working with two sample proportions, and we are going to run a hypothesis test in this one. So this is back to the drink up scenario. The company is testing the effectiveness of a new social media marketing campaign aimed at increasing online purchases of their popular energy drink among high school students. The company has an online customer base of over 1 million high school students. The company randomly signed over 2,000. That's important because random assignment tells me that I do not need to do the n is less than the n is less than 10% condition. One group of students were exposed to the new marketing campaign and the other was not exposed to the new campaign. It was found that 954 of the 1124 who were exposed to the new campaign made online purchase. All right, so I'm going to call this X1 here, this one EC, exposed to the campaign. And they said that of that 954 of 1124, so 954 over 1124. And the other group was not exposed and made a purchase, and that is 1,203 was the sample size and 875 made purchases. So 875 out of the 1,203, and I'm going to put not exposed for NE, for not exposed. All right, we might as well get our P hat 1 done and our P hat 2. We'll use them later. So our P hat 1 is going to be 954 over 1,124, 1,124. And this is going to be 875 over 1,203. That looks horrible. So 954 divided by 1124 is 0.8487. So about 85%. And the 875 divided by 1,203 is about 73% or 0.7273. And they ask us at an alpha of 0.01, does the marketing campaign increase online purchases? So let P1 equal the true population proportion of people who saw the new ads and made a purchase. Let P2 equal the true population proportion who made a purchase without seeing the new ads. All right, our hoe is going to be P1 equaling P2, that there is no difference between the group. And this is P1 and this is P2, but we have the P hat 1 and P hat 2 to label it. The alternative is going to be P1 and P2, same order, but it says they wanted to increase online purchases. So, I have that facing the wrong way. Because this group P1 saw the new ad, so they were exposed to new campaign, not exposed. So because I put it in this order, P1 needs to be greater than P2. If I'd swapped the order, then obviously the inequality would have flipped. All right, because it's a hypothesis test, we have to calculate P hat C, and we need that formula. Well, P hat C equals X1 plus X2 over N1 plus N2. We need to go ahead and plug in and figure what that out is so that we can do our conditions. P hat C equals X1 is 954 plus X2 is 875. And then we have 1124 plus 1203. So 954 plus 875 is 1829. And 1124 plus 1273 or 1203, excuse me, is 2327. So 1829 divided by 2327. is about 78%, so 0.7859. I'm going to go ahead and take a moment real quickly and run this thing. So let's go ahead and run the test. That way we can verify, make sure that we have our numbers right. So we have a two proportion z-test, which is number 6. We have 954 in group 1, 954 of 1124 purchased, and then 875 of those who did not see the ad. 875 of the 1203 did not see the ad purchased. We have a greater than symbol, so I need to make sure that I have a greater than symbol selected. And I end up getting a really large z-score and a very small p-value, but let's check out our other values. There's p hat 1, here's p hat 2, and sure enough, p hat c is 0.7859, which is what I have recorded right there. So it looks like I have those values right. We'll come back and might as well write down our p-value and our z-score. Since we have them, we're going to record those down low. Our z-score happens to be probability z is greater than 7.1356. And when we have a negative 13, well, anytime we have more than 4 zeros, and here we're going to have 12 zeros in front, we can say our p-value is approximately 0. They wanted us to test at 0.01. And 100 is definitely bigger than 0. So our decision right here is going to be very easy to reject the null. Well, here we go. We'll reject that hope. All right. So let's do our conditions. Condition number 1 is random assignment. And that was given. Over here, we have random assignment. And that was also given. And if you want to say what the size of the sample is, that's fine. We have 2 independent groups. And that was given. Number 3, that's the n is less than 10% condition. We don't have to do that because we have random assignment, but I'm going to go ahead and write that there's a number 3 just so that we don't forget that existed. Now we need to do is normality. Normality for the hypothesis test is different than the confidence interval. For confidence interval, it's N1 times P hat 1, but here we have to use P hat C. So N1 times P hat C and N1 times 1 minus P hat C. Over here, N2 times P hat C, and then N2 times 1 minus P hat C. Well, first off, what was N1? N1 is 1124. So 1124 times 0.7859. And this is 1,124 times 1 minus 0.7859. So 1124 parentheses 0.7859. Oops. 1124 parentheses 0.7859, close those parentheses. We'll get 883. That's greater than or equal to 10. Always got to make the comparison. 1124 parentheses 1 minus 0.7859, close those parentheses. And we get 240 is approximately 240. And that's also greater than or equal to 10, so we're good to go. All right, so this one, they're large enough to use the normality because we need to be greater than 10. On the other side, we have 1203 times that 0.7859. And here we have 1203 times 1 minus 0.7859. And we get 945, which is plenty big, equals 945. And that's greater than or equal to 10, so that checks out. And over here, for the next one, 1203 parenthesis 1, minus 0.7859. And we get 257. So in this case, this group is also greater than 10, so it's large enough to use the normal approximation. So our formula, Z equals P hat 1 minus P hat 2 P hat C, 1 minus P hat C over N1 plus P hat C times 1 minus P hat C over N2. Notice this is different than the confidence interval. Confidence interval, this is going to be P1 and this is going to be P2, but here it's just P hat C. So the numerators down here are the same. All right, so we need to plug in. Well, we have P hat 1 and P hat 2 from up top. And we know that we want a greater than from our hypothesis. So we're looking for the probability that Z is greater than 0.8487 minus 0.7273 and P hat C is 0.7859. .7859, 1 minus 0.7859 plus 0.7859 times 1 minus 0.7859. And our sample sizes were 1124 and 1203. Well, we've already decided to reject the null, so we're going to go ahead and move on to writing. It says conditions, but this shouldn't say condition. This should say, and I thought I'd fix that. That should have said conclusion. So our conclusion, our P value is approximately 0. What was our decision? We reject the null. Why? We have plenty of evidence. There is sufficient evidence at what alpha level? Oh, at alpha equal 0.01 to suggest that the true population proportion of people who make purchases after seeing the new ads is, what was our alternative? Greater than those who did not see the ads. Basically, we're saying, you know what? If you saw the ads, you're more likely to make a purchase than those who didn't see the ads, which means the advertising campaign seems to be working, seems like it's a good idea. All right, I sure appreciate you watching. Hope to see you on the next one. Thank you.